Hello, and this time we're talking about recursive sequences, which is just a formal way of doing a term-to-term rule. So you might sort of look at these and think, oh goodness, all these n+1s and n's, but all it is saying is how can you work out the next term in the sequence from the term we already know. So with these, it's not possible to go straight to the 100th term, but we can work out if we know the first term, okay, then we can say, okay, well, if we know the first term, we can put it in here, and we can do this maths and find out the next term, the second term in this case. So the way these are written is very much saying that the thing we don't know, so term n+1, and I do it as a subscript rather than in a bracket like they have here, t of n+1 is saying the next term, hence +1, is, in the first case, it's saying 3 lots of the current term plus 2. So let's say I want to know the first 5 terms of the sequence. Well, they've already told me the first term. I couldn't do it if I didn't. It doesn't tell me where the sequence starts. All it tells me is how to go from the current term, tn, to the next term, tn+1. So they've told us the first term is 0. Well, that's dead easy then, 0. The second term, yes, if we put the first term in here, that's t1, the first term, that's 0. Then the t of 1+1, that's t2, the second term, is 3 lots of the first term plus 2. So 3 times 0 is 0, plus 2 is 2. If we do that again, then we'll get the third term. If we put the second term in here, then the next term, the third term in this case, is 3 times the 2, which is 6, plus 2, which is 8. And we can go again. We can work out the fourth term from the third. So the next term is 3 times the current term, so that's 24, plus 2, so that's 26. And the last term, the fifth term, which is what I wanted, is we've got to put the fourth term in. The fifth term, the next term, is 3 times the current term, so 3 times 26, plus 2. So 3 times 26, I want to say, is 78, plus 2 is going to be 80. And so I found the fifth term, or indeed maybe I was asked for all 5 of these terms. I found them, but there's no quick way to go to the fifth term. Now you might ask, why is this necessary? Well, if you look at this question, it looked quite easy, 3 times plus 2, but this has not given us a nice sequence. We're used to arithmetic sequences, which you add the same amount each time, and that's not happening. What we're adding here, 18, and then, wow, we're adding 54. So we're used to having sequences that you add the same amount, and this is not happening. The amount we're adding goes up and up and up. Or geometric sequences where we times by, but that's not happening either. Okay, so the only way to write this sequence, at the moment anyway, is with this recursive relationship, basically just saying it has a complicated term-to-term rule, and we can write that formally as saying the next term in the sequence is 3 lots of the current term plus 2. Now, it might be that if you look at this in more detail, it might be a quadratic or a cubic. I don't know, and that's not the point. The point is, if it's not a nice, easy arithmetic or geometric, then there might be an easy way of writing it down as this sort of posh way of writing the term-to-term rule as a recursive relationship or recursive sequence. Let's do the second example as well. So this is saying the next term is 1 minus the current term squared. And again, they have to tell you a term. You can't work it out. They could tell you this term, and you could carry on, and you could even sort of work it backwards. But they have to tell you one of the numbers, because this is a sort of from one term, work out the next term situation. So the first term is 2, because they told me so. And the second term is 1 minus the square of the first term. So 1 minus this number squared. 2 squared is 4, so 1 minus 4 is going to be minus 3. And now we can work out the next term based on this as the current term. So the next term is 1 minus the square of the current term. Well, the current term squared is going to be 9, positive 9, because you always get a positive number from squaring. Minus 3 times minus 3 is 9. So that's 9, and 1 minus 9 is minus 8. And the fourth term is going to be worked out from the third term. So we put this number in here, and we say that the next term is 1 minus the square of the current term. Minus 8 squared is 64. So 1 minus 64 is minus 63. And you can see where this is going, although I'm going to need a calculator for the fifth term now. So here's my calculator. I'll just put it back onto its standard setting. And so I'm going to say, okay, it's 1 minus, 1 minus the current term. Okay, now be careful, we do need it in a bracket if we're going to type it in like this, because if I don't put that in a bracket, it won't square the minus sign. So you have to be very careful. So in a bracket, minus 63 squared, and it just tells us that it's minus 3968. Okay, and just check I copied that down right. Yes. So there's my 5 terms for my sequence, each number worked out from the previous number using the recursive sequence. Now, finding a recursive relationship isn't particularly easy. You have to, it's like working out what's the term-to-term rule, but knowing that it's going to be a bit complicated like this. Working out that this was times by 3 add 2 isn't particularly straightforward. It's an element of puzzling. And if you are asked to do this in an exam, it should be something relatively easy. So if we just look at this and just see, well, what's going on. So very basically, 3 to minus 1 is take away 4. And actually, look, minus 1 to minus 5 is also take 4. So they've been kind, they've given us an arithmetic sequence. So in order to find the next term in the sequence, all we have to do is take away 4. So we can write this as tn plus 1, the next term, is whatever term you've got at the moment, tn minus 4. Okay, that's all we're doing to get from one term to the next. So the next term is the current term, take away 4. Now this looks slightly harder because there's something happening with minus signs and there's something happening, the numbers are getting up quite quickly. But again, I think they've given us an easy question. It's very unusual to be given a complicated one like this to find the relationship. It's easy to use the relationship, you just keep substituting the number in. But to find the relationship, that's not necessarily that easy. So that's why these ones are much easier when you're trying to work out what the sequence is. So let's think. 3 to 9 would be times by 3, but it changes to minus. And then 9 to 27 is also times by 3. So I think it's timesing by 3 each time, but because it's going positive to negative, it's timesing by minus 3, by minus 3, by minus 3. And that will make it go bigger, but keep switching it from a positive to a negative number at the same time. So again, it's nice straightforward because there's just one step in the term-to-term rule. So it's been easy to see. So we can just write this as tn plus 1. The next term is the current term times by minus 3. So we can just say minus 3tn. And we know that 3t, 3 next to the t just means times. We don't need to put the time symbol in. So hopefully you can see that actually with a relatively easy, what seems like a relatively simple term-to-term rule, we can get a pretty, weird sequence that doesn't grow in a way that we're used to seeing in an arithmetic or geometric way, and would be quite hard, potentially, to find an nth term rule for, but the term-to-term rule describes it quite well. And all a recursive sequence means is just saying we've got this formula which uses the last term to work out the next term, which is the term-to-term rule. It's just written more formally as t, the value of the n plus 1 term, the next term, as a function, so as doing a bit of maths on the current term, t of n, wherever you are. So if you want the 100th term, you need to know the 99th term. So to get the 99th term, you need the 98th, and so on. So it will only work building it up. You can't scooch straight to the 100th term without going through the motions and working them all out. If you have any questions on that, then you can let me know in the comments. But for now, cheerio.